Okay, this is going to be problem 6 from page 274. Again, we're going to do a Cramer's rule problem, but I'm going to go through it at a regular pace. I'm not going to talk through step by step. So, here I have my equation. The first thing that I want to do is rewrite it so that I have everything in line, x's and then y's, and then my constants on the other side of the equal sign. So here I'm going to fix it. I'm going to add y to both sides. 6x plus y equals 2. Here I'm going to move my 1 to the other side, my 2y, so I get 3x minus 2y equals negative 1. Now I can come out with my coefficient matrix. My coefficient matrix will look like 6, 3, 1, negative 2. And my d, or the determinant of my coefficient matrix of 6, 3, 1, negative 2, will equal 6 times negative 2 minus 3 times 1, which is 12 minus 3, negative 12 minus 3. 6 times negative 2 is negative 12. And negative 12 minus 3 is negative 15. So here my d equals negative 15, or the determinant of my coefficient matrix equals negative 15. Now I'm ready to move into the next step for Cramer's rule. I need to find my x value. My x will equal a modified version of my coefficient matrix. It'll be C1, C2, B1, B2, the determinant of that, over D. In this case, I've got my A column, my B column, my C column. That's A1, B1, C1, A2, B2, C2. So to find my x, I'm going to replace my x coefficients. My C1 is 2, my C2 is negative 1. 2 and negative 1. I keep my y coefficients, 1 and negative 2. And I know my d value is negative 15. My x is going to equal 2 times negative 2 minus negative 1 times 1 all over negative 15. So again, my x will equal, simplifying it down, negative 4 minus negative 1 over negative 15. My x will equal, minus and negative becomes a positive, negative 3 over negative 15. And I can reduce that. The negatives cancel to 1 over 5. So x equals 1 over 5. There's half my solution. Now to find my y value, I'm going to keep my a coefficients, my x coefficients. To find the y, I'm going to replace the y coefficients with my c's. Find the determinant of that. It's all going to be over d. So y will equal, my x coefficients are 6 and 3. My c is c1 and c2 is 2, negative 1. And my d, again, the determinant of my coefficient matrix is negative 15. Y equals 6 times negative 1 minus 3 times 2 all over negative 15. Y equals, let's see, 6 times negative 1 is negative 6. 3 times 2 minus 3 times 2 is just 6 all over negative 15. Negative 6 minus 6 is negative 12 over negative 15. Negative and a negative. Negative divided by negative becomes positive. So I can simplify 12 over 15. If I divide the top by 3 and the bottom by 3, I get 4 over 5. Y equals 4 over 5. So my solution to this system (1 over 5) 4 over 5. 1/5 and 4/5 is the solution. We can plug them back into here, and I can verify that that is in fact a solution when I plug my x value in and my y value in. Here's my solution, and we'll double check it. 6 times 1 over 5 plus 4 over 5 should equal 2. 6/5 plus 4/5 should equal 2. 10 over 5 equals 2. That works in that one. And we could check it in the other equation as well. 3 times 1 over 5 is 3 over 5. And then negative 2 times 4 over 5 is negative 8 over 5. And that was supposed to equal negative 1. My denominators are the same, so 3 minus 8 is negative 5 over 5, and that should equal 2, negative 1, and it does. My solutions are good. 1/5 and 4/5.